Hi everyone, this video is part of Unit 3, it's Lesson 4, on writing small numbers in scientific notation. Before you start, make sure you've got a pencil and your packet to take notes. Remember that you can pause and rewind the video as many times as you need. Let's start. Powers of 10 can also be used to express small numbers in scientific notation. Remember, up to this point, we have only talked about very large numbers. A single red blood cell is about 0.000007 meters in diameter. In what place is the 7 in the value? Well, remembering place value to the left of the decimal is the whole number, and then it goes tenths, hundredths, thousandths, 10,000s, 100,000s, and millions. So that 7 is in the millionths place. What power of 10 relates to this value? Well, a million, and it's a small number, is going to be in the denominator, like a 1 over 1 million. If a million looks like that, that is 10 with 6 zeros, so 10 to the 6th power. And I know from an earlier lesson that if it's a positive exponent in the denominator, I can move it up to be a negative exponent in the numerator, or 10 to the negative 6th. So a number in the millionths place is like a 10 to the negative 6th. So putting those two things together, if I express that number in scientific notation, it's going to have a times 10 with an exponent of negative 6. Just like with very large numbers, the number out front in scientific notation has to be between 1 and 10. So in this one, I would move that decimal until it's right here after the 7 to make it a 7.0, which could also just be 7. So that number in scientific notation is 7 times 10 to the negative 6th. Density of oxygen is 1,332 millionths of a gram per cubic centimeter. Express this value as a decimal in standard form. You need to know my place value. After the decimal, it goes tenths, hundredths, thousandths, then 10,000s, 100,000s, and millions. So that last number 2 is going to be in the millionths place. Then writing backwards from there, I'm going to fill in the missing zeros, and it will be 0.001332. In scientific notation, I need a number bigger than 1 and smaller than 10, so the decimal has to be between the 1 and the 3. I need all of the non-zero numbers, so I need the 3 and the 2 as well. Then it's always times a base of 10, and to get it there, we move it 1, 2, 3 times, because it's a small number, a negative 3. 1.332 times 10 to the negative 3rd. The Mycoplasma's bacteria is about 2.5 times 10 to the negative 4th millimeters in size. Express this number in standard form, which is the opposite of what we just did to get it into scientific notation. If I start with the number 2.5, the negative 4 says it's small, so I'm moving that decimal 4 times to the left. 1, 2, 3, 4. Now it's there, and I'm filling any blanks with zeros. So in standard form, that number is 0.00025. Pause the video here while you copy the tables and try to fill in. Try to switch them from scientific to standard or back. Let's see how you did. 10 to the negative 4th, I'm going to move it 4 times, which is past the 7, and then I'm going to need 3 more zeros for those spots, so 0.00072. In the next one, I'm going to place the decimal between the 1 and the 8 to make it 1.8, always times a base of 10, and we had to move it 1, 2, 3, 4, 5, 6, 7 times, so an exponent of negative 7. If you didn't try the bottom two, go ahead, pause here, and try to fill in those on your own. Hopefully, you wrote a 2.6, and then you counted 1, 2, 3, 4, 5, 6, 7, 8 times to get an exponent of 10 to the negative 8th. And 10 to the negative 3rd is moving it 3 times, 1, 2, 3, filling in the blanks with zeros is a 0.0052. Pause here if you're still writing. More practice, express each number in standard form. Notice that A, the number 3, doesn't seem to have a decimal. 3 is the same as the number 3.0, So remember, the decimal is after the 3 to start with. So we're going to move it 8 times to the left. That means I'm going to move it once with 7 more zeros. So don't forget that leading decimal and then 7 zeros. And just the number 3. 10 to the negative first is moving it left just once, so we aren't going to need any extra zeros. I'm just moving that decimal in front of the 1. So it's a 0.1239. Both of those answers could also have a leading 0 in the whole number place to the left of the decimal, but it's not required. Now your wrap up or take it out the door. Match each value on the left with its expression in scientific notation on the right by drawing lines to connect the equivalent expressions. Pause here while you try to match the scientific and standard notation of those numbers. Doesn't matter which one we start with, so I'm going to skip the ones with words first and start with the second one, 0.988. I only have to move it one time to get it between the 9 and the 8, and that'll make it 9.88. Since they all have 9.88, that didn't narrow it down, but we moved it once, so it's to the negative first. Whereas the next one, to get it to the 9.88, we move it 1, 2, 3 times, so I'm looking for an exponent of 10 to the negative third. And then 1, 2, 3, 4, 5 times, so a 10 to the negative fifth. That leaves our first one and our last one. 988 10,000ths. Well, after the decimal goes tenths, hundredths, thousandths, 10,000ths. So there have to be 4 numbers, which would make it 10 as a placeholder and 0.0988. I'm moving that decimal twice to the right to make it 9.88, and it'll be times 10 to the negative second, which leaves 988 millionths to be 9.88 times 10 to the negative fourth. After this lesson, you should now be able to do the new homework. It's quizzes, scientific notation, small numbers, and hopefully you already have the first 2 done. Remember that you need an 80% or above or 100% to get your extra point. Every module, you are required to pass one teacher-assigned lesson in iReady. You have the 3 options below. The middle one kind of matches what we were doing if you want more practice on that. But you can pass any lesson for a 10 out of 10 or extra lessons for extra credit. Good luck.